Now we are going to cover the topic SAP HANA Architecture. In this session, I'll be showing you the SAP HANA database system architecture, and then I'll be showing you in detail the SAP HANA index server, that's the main server in SAP HANA architecture. And later on, I'll be showing you the difference between row store and column store. So as it's widely popular that SAP HANA is a leading in-memory database and it's a data management platform which is specifically developed to take full advantage of the capabilities provided by the modern hardware to increase the application performance. So by keeping all the relevant data in the main memory, data processing operations are significantly accelerated. So what's the reason behind that? The reason is the architecture of SAP HANA. It's the key for SAP HANA to be a game-changing innovative technology. It has been designed so well architecture-wise such that it makes a lot of difference when compared to other traditional databases available today. The enterprise application requirements have become more demanding. That means that complex reports with high computation on huge volumes of transaction data and also business data of other formats is required. So data is being written or updated and also read from the database in parallel. So integration of both transactional and analytical data into single database is required. So that's where SAP HANA has evolved. It implements columnar storage, which exploits the modern hardware and technology because there are multiple CPU cores and large main memory and cache. So that achieves the requirement of enterprise applications. So you can see on your screen the various services of SAP HANA database. In this, index server is the most important component of all the servers. Other servers are name server, preprocessor server, statistical server, and access engine. So we have client applications as well. SAP HANA can accommodate multiple clients across multiple instances to provide access to useful data across a number of related applications. You can see over here there's a client application SAP ERP. So SAP HANA can also connect via an optional module, that is Access Engine, to a client application via HTTPS. This is helpful for obtaining third-party data or data from disparate locations. So it's currently not recommended to attach more than one ERP per instance of SAP HANA due to the potential for table name replication, as SAP HANA database is a non-locking database, right? So next is we have the index server. This is the server which is the most important server. It holds the actual data and the engines for processing the data. So when SQL or MDX is fired against the SAP HANA system, in the case of authenticated sessions and transactions, then in this index server takes care of these commands and then it processes these commands. So it also coordinates and uses all the other servers. So this is the place, the index server is the place where most of the SAP HANA magic happens, and we'll be covering this in detail. I'll be showing you various components inside index server. Then we have name server. This server holds complete information about the system landscape. Name server is responsible for the topology of the SAP HANA system. So in a distributed system, SAP HANA instances will be running on multiple hosts. In this kind of setup, the name server knows that where the components are running and how data is spread on different servers. So that's the purpose of the name server. Then we have the preprocessor server. This server comes into the picture during text data analysis. Index server utilizes the capabilities of this preprocessor server in text data analysis and searching as well. So this helps to extract the information on which text search capabilities are based. So the purpose of preprocessor server is into text data analysis only. Then we have a statistical server, or we call it statistics server. This server helps in collecting the data for the system monitor, and it helps you know the health of the HANA system, right? So the statistical server is responsible for collecting the data related to the status, resource allocation or consumption, and the performance of the SAP HANA system. So monitoring the clients and getting the status of various alert monitors use the data collected by this server. It also provides a history of measurement data for further analysis. So it basically keeps a check on the health of the SAP HANA system. And then we have the Access engine. That is, Access is for extended services. This engine allows external applications and application developers to access the SAP HANA system via the Access engine clients. For example, a web browser accesses SAP HANA apps built by application developers via HTTP. So application developers build applications by using this Access engine, and the users access the app via HTTP by using the web browser. So the persistent model in SAP HANA database is converted into a consumption model for clients to access it via HTTP. This allows an organization to host system services that are part of the SAP HANA database. For example, search service, that's a built-in web server that provides access to the static content in the repository. So Access engine allows all the external applications and many application developers to access this SAP HANA system. So this was all about the architecture of SAP HANA database system. Now let me just shed some light on SAP HANA Index Server in detail, because this is the main server which contains the data, which handles all other servers, and it only processes all the commands. So it performs all the key functions to accelerate and optimize the analytics. So together these all functions provide good security and data protection and enhanced data access. So we have connection and session management over here. This component initializes and manages sessions and connections for the SAP HANA database using pre-established session parameters. So there are some session parameters which are used by connection and session management so that it manages all the sessions and the connections. As you must be aware about SAP, it has long been known for excellence in session management through its integration of SAP Router into the SAP GUI product used as a front end for accessing the ABAP stack. So SAP HANA retains this ability to configure connection and session management parameters to accommodate this complex security and data transfer policies. Then we have the SQL processor. The SQL processor segments data queries and directs them to specialty query processing engines for optimized performance. As there are many different kinds of engines you can see on your screen. We have the store procedure engine, we have planning engine, we have MDX engine, and then we have the calculation engine. So it basically divides all the data queries and then it directs them to the different engines for the optimized performance. It also ensures that SQL statements are accurately authored, and it provides some error handling to make these queries more efficient. So all these several engines are contained inside this SQL processor. The first is this multidimensional expression engine. We call it MDX engine. So it basically handles the multidimensional data stored in OLAP. It handles all the queries and it manipulates the multidimensional data in OLAP in basically our data cubes. Then we have planning engine. It enables the basic planning operations within the SAP HANA database for financial planning operations. Then we have Store Procedure Processor. It executes procedural calls for optimized processing without a reinterpretation. So, for example, converting a standard info cube into an SAP HANA optimized info cube. So, like that, it handles all the procedural calls. So, it's meant for stored procedures only, for processing those stored procedures. Then we have the calculation engine. It basically converts all the data into the calculation models, and it creates a logical execution plans to support parallel processing so that all those processing can be done in parallel. So the purpose of calculation engine is creating the calculation models and creating those logical execution plans. Then we have the relational stores with us. See, SAP has further segmented the storage of in-memory data into compartments within memory for speedier access. Traditionally, all the database management systems are relational, and they store the data row-wise. So I'll be showing you that in detail later on. So now the data not needed immediately is stored on a physical disk as opposed to RAM. So this SAP HANA handles this thing as well. It's known as in-memory database, but yes, when the data is not needed immediately, it's stored on the physical disk. So this allows quick access to the most relevant data. So the SAP HANA database houses 4 relational stores that optimize query performance. One is row store, column store, object store, and then is disk space store. I'll be getting into the details of row store and column store. Basically, row store is just that it stores the table records in a sequence of rows in the memory, and column store is it stores the table records in the sequence of columns. So the entries of a column is stored in contiguous memory locations. So that way these are totally different storage options we have. Then we have the disk-based storage, in which when the data is not required, then it is stored on the disk. It's not stored in the memory. Object store is the integration of SAP Live Cache technology into SAP HANA database system. Then we have our transaction manager. The transaction manager is the component that coordinates database transactions, and it takes care of controlling transaction isolation, and it keeps track of running and closed transactions. The transaction manager informs the involved storage engines about the running or closed transactions so that they can execute necessary actions. When a transaction is committed or it's rolled back, then it has to perform certain actions, and then it informs the involved storage engines about that. So the transaction manager cooperates with the persistence layer to achieve atomic and durable transactions. The client requests are analyzed and executed by a set of components summarized as request processing and execution control. So the client requests are analyzed by a request parser, then it is dispatched to the responsible component. The transaction control statements are then forwarded to the transaction manager. So the data definition statements are sent to the metadata manager, as you can see over here. The object invocations are dispatched to the object store. The data manipulation statements are sent to the optimizer, which creates an optimized execution plan that is given to the execution layer then. So the SAP HANA database has got this built-in support for domain-specific models, such as for financial planning domain, and it offers scripting capabilities that allows application-specific calculations to run inside the database. It has its own scripting language which is called SQL script, which is designed to enable optimization and parallelization. So this SQL script is based on free functions that operate on tables by using the SQL queries for set processing. So the SAP HANA database also contains, as I have explained you before, that we have this planning engine which allows the financial planning application so that it executes the basic planning operations in the database layer. So we have these different engines to perform different functions for like we have the planning engine to perform this financial planning for the financial planning applications. We have this metadata manager which helps to access the metadata. SAP HANA database metadata consists of a variety of objects. For example, definitions of tables, views, indexes, or SQL script function definitions, and object store metadata. So all these types of metadata are stored in one common catalog for all the SAP HANA database stores. So metadata is stored in the tables in the row store. The SAP HANA features such as transaction support and multi-version concurrency control are also used for metadata management. Central metadata is shared across the servers in case of the distributed database system. And the background mechanism of metadata storage and sharing is hidden from all the components that use the metadata manager. So then we have the persistence layer. This layer is responsible for durability and atomicity of the transactions. It ensures that a database is restored to the most recent committed state after a restart, and it makes sure that the transactions are either completely executed or completely rolled back. To achieve this in an efficient way, this persistence layer uses a combination of write ahead logs or shadow paging and save points. So it also offers interfaces for writing and reading data, and it contains this SAP HANA's loggers that manages the transaction log. So that's the purpose of the persistence layer. We have over here the authorization manager also. This authorization manager is invoked by other SAP HANA database components to check the required privileges for users to execute the requested operations. So privileges to other users or roles can be granted based on that. A privilege grants the right to perform a specified operation such as create, update, select, execute, all these data manipulation. So on a specified object such as a table or a view and SQL script function. So analytical privileges are there which represent filters or hierarchies, and they drill down limitations for analytic queries. So analytic privileges such as granting access to values with a certain combination of dimension attributes are also supported in SAP HANA. And users are authenticated either by SAP HANA database itself, that is the login username and password, or the authentication, this authentication which is there, it can be delegated to the external authentication providers, third parties such as LDAP directory. So there are various methods for authenticating and giving the authorizations. Now this is the right time to get into the detail of row store and column store, as this is a very important concept on which SAP HANA database is built. That's the main technology it's using. So let's get into that. So see, we have this table wherein these are the different records for these columns: country, product, and sales. And first record is US Alpha 3000, like that. These are the different records. And on the right side you can see that there are two ways to store the data. One is the row store, the other is the column store. In the row storage, it stores the table records in a sequence of rows. So first row will be stored, then next row will be stored, and then next. So the whole row is stored in contiguous memory locations. So that's the way the row storage works. In case of column store, it stores the table records in a sequence of columns. That means the entries of a column is stored in contiguous memory location. You can see over here, first the whole column is stored over here. That is US, JP, UK. First that column is stored, then next column is stored. Alpha, beta, alpha, alpha. So you can see over there. So that's the way the data is stored in the column store. Okay. So the row store is the SAP HANA database, row based in memory relational data engine. We have these data engines. One is the row store engine, data engine in SAP HANA, which is optimized for high performance of write operations. So we use that engine when we need to write the data into a SAP HANA database. And we have this column store. That's the HANA database column store in memory relational data engine, which parts of which it originates from TREX. If you have heard about TREX, that is text retrieval and extraction. That's SAP NetWeaver search and classification. So for the SAP HANA database, this proven technology, the TREX, it was further developed into a full relational column database store, and it's efficient data compression, and it's optimized for high performance of read operation. So the data is read using this engine, the column store engine, and the data is written into it using the row store data engine. So otherwise, the relational databases typically use this row based data storage, and whereas this column based storage is more suitable for many business applications. So SAP HANA supports both, and SAP HANA is particularly optimized for column based store, and it's thus this combination of both the storage approaches which produces the speed, the flexibility, and performance of the HANA database. The engine that is used to store the data can be selected on a per table basis at the time of creating a table. When we create a table, there's an option that whether you want to create the table as a row based table, object based table, or a column based table. So tables in the row based store are loaded at startup time, but in the case of column based stores, the tables can either be loaded at startup or on demand, that is during normal operations of the SAP HANA database. So it's not compulsory to load the data into the table of column based table during the startup. So both these engines share a common persistence layer which provides data persistency that is consistent across both engines. Like a traditional database, we have page management and logging in SAP HANA. So the changes made to the in-memory database pages are persisted through save points, and these save points are written to those data volumes on the persistent storage, for which the storage medium is hard drives. So all the transactions committed in SAP HANA database are stored, are saved, and referenced by the logger of the persistency layer in the log entry, which is written in the log volumes of persistent storage. As you can see over here, we have this logger over here, and we have this page management also over there. So this whole procedure is done in the persistence layer. So this is how it uses the column store engine. Then what's the advantage of column based table? See, as the data is stored here column wise, we have faster data access, because only the affected columns have to be read during the selection process of a query. Any of the columns can then serve as an index, which provides us faster access. Then we have better compression, because columnar data storage allows high highly efficient compression because the majority of the columns contains only few distinct values as compared to the number of rows. So due to that we have better compression, and then we have better parallel processing as well. So in the column store, the data is already vertically partitioned. Okay, so this means that the operations on different columns can easily be processed in parallel. If multiple columns need to be searched or aggregated, each of these operations can be assigned to a different processor core, and because we have multiple cores as well. So that way we have this better parallel processing with column store. Now, what are the advantages of row based? See, when the application needs to only process a single record at one time, then in that case we use row store engine. Then if we have the application typically needs to access a complete record, the whole record, right? Not only few columns, but the whole record. Then also we use it. Then it's advantageous to use it. Then if there are no aggregations or no fast searching is required, then also you can go for row store. And if the table has a small number of rows, then we can also, then that doesn't make any big difference if we use row store or column store. But it has got one major disadvantage, that is in case of analytic applications where aggregation is used and fast search and processing is required. So in row based tables, all the data in the row has to be read, even though the requirement may be just to access a few columns, but we'll have to pick the whole row in that case. So that's the major disadvantage of row based store. So in case of analytic applications where aggregations are used and fast search and processing is required, the row-based storage are not good. In row-based storage, all the database has to be read. I've just told you that it has to, even if few columns are required, all the data has to be read. So these queries on huge amounts of data take a lot of time. So we don't use for those analytical applications where aggregation is required. In columnar tables, this information is stored physically next to each other, significantly increasing the speed of certain data queries. So in that case, the column store is better. So to enable fast on-the-fly aggregations, ad hoc reporting, and to benefit from compression mechanisms, it's recommended that the transaction data is stored in column-based table. So the SAP HANA database allows joining row-based tables with the column-based tables. However, it's more efficient to join tables that are located in the same row or the column store. So basically, when we need to read the data, when we need to aggregate the data, when we need faster processing, and we need on-the-fly aggregations, ad hoc reporting, then and much of this because of compression, we go for column store. So that's the whole criteria behind this column store. Because of these advantages, this SAP HANA is leveraging this column store technology, and that's why it's become so fast. It's in memory, and it's all the data is stored in the memory on the basis of this column store architecture, and it's the processing is just too fast. So that's the reason behind it. So it was all about row store and column store differences, and we have the option of storing the table as a row store or a column store when we create the table. And we have just seen all the components of index server in detail, and this is the main architecture of SAP HANA database system. And there are these different servers are there which have got their own purposes, and these are all managed by this index server. That's the main server. So that was all about SAP HANA database system architecture.